Alright, so in 7.4 we're going to be talking about something called a confidence interval. So when conducting a survey, we want to know within what interval we might see results. So let's just go ahead and look at this example. So a research center took a random sample of 654 registered Democrats in the United States in 2013. In the sample, 57% agreed that the news media spent too much time on unimportant news. What can we say is the percentage of all Democrats in the U.S. that agree with the statement? How much larger or smaller may that 57% actually be? Keep in mind we don't actually know the population parameter p. So, to answer these kinds of questions, what we are going to look to is we are going to look to the empirical rule as well as the central limit theorem. Okay? So just because our sample said that 57% of Democrats agreed with that doesn't mean that 57% of all Democrats. That's only in our sample. So since we randomly sampled these people, we can assume that we're not going to have any bias, so we assume that our sample is going to be pretty close to our population. Similarly, we can estimate how far off we are by using the standard error estimate. So if we want to determine in which interval our Democrats will fall, first we need to find out the margin of error. Okay, that's going to tell us about how far off we can expect our estimate to be. Okay, so typically our margin of error is 2 times the standard error. That's going to give you a 95% interval by the empirical rule. Okay. Now the confidence level is going to provide you with 2 pieces of information. It's going to give you the interval and the percent chance p is on the interval. So first off, let's go ahead and find the standard error given the example above. So we had that p hat was 57%, which is 0.57. We also had that our sample size was, I think it was 654. So our standard error estimate, which you can also just call standard error, that's fine too, is going to be the square root of 57 times 1 minus 0.57 divided by 654. Okay, and let's just go ahead and round that to 2 decimal places just to make our lives a little bit easier. All right, so that's going to give us 0.02 if we round to 2 decimal places. All right, so a range of plausible values for a population parameter, okay? If we want to look at it with 68% confidence, we would say that the population, which remember is called p, is going to fall somewhere. So if we're doing if we're doing 68% confidence, then that is going to be p hat plus or minus just a single standard error. Okay, so that would go down to 55%, and it would go up to 59%. So we are 68% confident that the actual amount of Democrats that agree with that statement is somewhere between 55% and 59%. Now, when we're calculating our confidence levels and our margin of error, there's going to be a relationship. So the more confident you are, the bigger your error is going to be. So if you want to be 95% confident, that's going to be about 2 standard errors away. Or if you want to be really exact, it's actually 1.96. Okay. If you wanted to be 68% confident, which is incredibly low, nobody's really that wants to be that low in confidence, that would be 1 standard error. So remember, the margin of error is about how far off you think you are from the actual population. Where we get the most bang for a buck is the 95%. Okay, and the way that's going to be calculated is that's going to be p hat plus or minus 2 standard errors. Okay, so just as a little summary, it's p hat plus or minus the margin of error, so about how far off in percentages you're going to be. And that is plus or minus, you'll see this in the book, they call it z. Okay, remember z is how many standard errors you are away times the standard error. So usually that's going to be about 2. All right, so let's go ahead and look at an example of this. Suppose there is a claim that 57% of high schoolers drink 3 or more caffeinated beverages a day. We survey a random sample of 2,100 high schoolers and find that 24% of them, 24% drink 3 or more caffeinated beverages. Okay, so what we're going to do is that we're going to find the standard error. We're going to find a 95% confidence interval for the percentage of high schoolers who drink 3 or more caffeinated beverages. And we want to know if it's actually plausible to conclude their claim given what we saw in our sample. So first off, p equals 0.57. The standard error, if you know p, use p to find your standard error. That is going to be 0.57 times 1 minus 0.57 divided by, remember, the size of our sample, which was 2,100. And again, let's just round that to 2 decimal places to make our lives a little bit easier. So that would be 0.01. So what that means is that there's a 95% chance that we would take our survey and see between 55% to 59%. Now, what this means is 2 things. Either, since 24% is not on this interval, either the claim is false, our sample is bad. Right? Those are the 2 choices that we get to make. And later on, we're going to decide which one we make. So,